Season 1, Episode 4 asks us to find the y-coordinate of the stationary point on this curve. Now, stationary points. The important thing to remember about stationary points is they're always when the gradient is equal to 0. So first we need to find the formula for the gradient, then find, well, what's the value of x when the gradient is 0. So gradient dy dx. So first thing we do, find gradient formula, differentiate as per normal. 2 comes out the front, we'll get 2x, x to the power of 1, 1 comes out the front, leaves us but just take away 3. So that's our formula for dy dx. Stationary points are when dy dx equals 0. So when dy dx, our gradient is 0, 0 equals 2x, take away 3. Solve for x. Add 3 to both sides. To get x by itself, divide both sides by 2. So x is 3 over 2. Leave it as a fraction, though you probably could get away with the 1.5 as well. But we're not finished because the question asked for the y-coordinate. Well, we've got an x-coordinate. How do we find the y-coordinate? Thankfully, we have a beautiful formula there that turns x-coordinates into y-coordinates. So, to find y-coordinate, y is equal to, putting our value for x in here, so 3 on 2 squared, take away 3 times 3 on 2 plus 2. All maths here, you can put that in a calculator if you really want, but you'll probably do better marks-wise if you don't. 9 on 4, take 9 on 2 plus 2. Need them all in the same denominator if I'm going to work that out. Lowest common denominator is going to be 4. 9 on 4, take away 18 on 4 plus 8 on 4. So that'll be negative 9/8 at that point. No, sorry, negative 9 over 4 at that point, plus 8, negative 1/4. So therefore, the y-coordinate at the turning point, at the stationary point, which is a turning point in this case, the stationary point is at 3 on 2, negative 1/4.